Let's talk about capacitors. Capacitors are devices that can hold electrical charge temporarily. So the main function is to store electric charge. So a parallel plate capacitor consists of two parallel plates. They're conductors, separated by a non-conducting medium. You can call it dielectric. This is a parallel plate capacitor. I'm going to connect these two plates to a voltage source. The top plate is connected to the positive side of the battery and the bottom plate is connected to the negative side of the battery. I'm increasing the voltage from, let's say, 0 volt to 10 volt. That will increase the charge on the capacitor. A lot of positive charges on the top plate, a lot of negative charges on the bottom plate. Anyways, that will increase the charge. So when you increase the potential difference, delta V, you are increasing the charge stored in the capacitor. So Q will increase as well. Now, if you decrease the voltage from 10 volt back to 0 volt, charge would be 0. So if you decrease the voltage, that will decrease the charge. So they have a direct relationship between them, delta V and Q. So Q is directly proportional to delta V. I want an equation. So I'm going to replace the proportionality sign with an equal sign. To do that, I have to multiply with a constant times delta V. That constant is capital C, capacitance. We call it capacitance. So if you want an equation for capacitance, rearrange this. C equals Q over delta V. That's the equation for capacitance. A unit of capacitance is farad. Capital F. Capacitance is a constant for a particular capacitor. It's not a universal constant, but it's a constant for a particular capacitor. But we can have different capacitors with different capacitance values. Let's do some problems now. Q equals 2.5 microcoulomb, delta V equals 10 volt, and we don't know the capacitance. How do you find the capacitance? The equation for capacitance is C equals Q over delta V. Q is the charge stored in the capacitor, that is 2.5 microcoulomb. Micro is 10 to the minus 6 coulombs, over delta V is 10 volt. 2.5 times 10 to the minus 7 farads. Next question, capacitance is 1 picofarad, delta V is 12 volt. What is Q? So capacitance is 1 picofarad. So 1 times 10 to the minus 12. Pico is 10 to the minus 12 farads. Delta V is 12 volt. So how do you find Q? So the equation is C equals Q by delta V. We need to find Q. So cross multiply, you'll get Q equals C delta V. Where C is 1 times 10 to the minus 12, which is 10 to the minus 12, times delta V is 12. The answer is 12 times 10 to the minus 12, which is, this is in farads. So 10 to the minus 12 is pico. So pico, 12 picofarads. Now, if you want to convert this 2.5 times 10 to the minus 7 farads into microfarads, let's say your options are in microfarads. So how do you convert this into microfarads? We have 10 to the minus 7 here. And micro is 10 to the minus 6. So 10 to the minus 7 plus 1 is 10 to the minus 6. Plus 1. To add a power, we need to move the decimal place to the left. Okay, we have added 1, so we have to move the decimal place 1 time to the left. So that will give you 0.25 times 10 to the minus 6 farads. And what is 10 to the minus 6? Micro. So 0.25 microfarads. Now, if your options are in nanofarads, Nano is 10 to the power minus 9. So 10 to the power minus 7 to 10 to the power minus 9. That is minus 2. Minus 7 minus 2. If you're subtracting the power, then you have to move the decimal place to the right. Then it's 2.5 times 10 to the power minus 7. So move the decimal place 2 times to the right. 250 times 10 to the power minus 7. Minus 7 minus 2, which is minus 9 farads, which is 250 nanofarads. That's how you convert. So we look at a different problem. This time we have a graph, a QV graph, a Q on y-axis and delta V on x-axis. So Q delta V graph. Q is charge, delta V is the voltage, potential difference. Let's say our graph should be straight line because they are directly proportional with positive slope. Yeah. Okay. So that's my Q delta V graph. How do we find capacitance from this graph? We have Q on the y-axis and delta V on the x-axis. Slope of this graph is general equation. It's y2 minus y1 over x2 minus x1. Slope m, or change in y coordinates over change in x coordinates. In our graph, y is q, right? Delta y is change in the q values. So q over, on x-axis we have delta v. So change in x coordinates means we are finding change in voltage, q by delta v. What is q by delta v? Q by delta v is the capacitance. Capacitance C. To find capacitance from a q delta v graph, q on y-axis and delta v on x-axis, just find the slope of the graph. Let's say our graph is like this. Delta v is on y-axis and q is on x-axis. It's a bit different. Again, it's a straight line because they're directly proportional. How do you find capacitance from this graph? It's a bit different. Again, slope is change in y coordinates over change in x coordinates. But in our graph, we have delta v on y-axis. So delta v over q. Delta v over q. That's the inverse of capacitance, right? So what we are getting is 1 by c. Okay. So slope equals 1 over capacitance. So how do you find capacitance? 1 over slope. If you have a q delta v graph, q on y-axis and delta v on x-axis, to find the capacitance, just find the slope. But if you have delta v on y-axis and q on x-axis, to find the capacitance, you have to find 1 over slope. Or find slope, then find the inverse of the slope. Consider the following delta v q graph and answer the following questions. Question A, what is the potential difference of capacitor B when charge is 1 nanocoulomb? Find the capacitance of capacitor A and capacitor B. We have two capacitors here, different capacitance values. Because the graphs are different. We have delta V on y-axis and charge Q on x-axis. Charge is given in nanocoulombs. Charge is in nanocoulombs. What is the potential difference of capacitor B when charge is 1 nanocoulomb? The question is about capacitor B. What is the potential difference? So you need to find delta V when charge is 1 nanocoulomb. There is 1 nanocoulomb. This is 1 nanocoulomb. So we have to find delta V. So draw a straight line to the graph. Connect it to the y-axis. You'll get delta V. So part A. From the graph, we have found delta V is 20 volt. Find the capacitance of capacitor A and capacitor B. We have two equations. If we have Q on y-axis and delta V on x-axis, capacitance is a slope. And if we have delta V on y-axis and Q on x-axis, then capacitance is 1 over slope. In this problem, we have delta V on y-axis and charge on x-axis. So the equation will be 1 over slope. Okay, so let's find slope for capacitor A. Capacitor A. I'm going to select 2 points. First point, let's say this one, 2 nanocoulombs, comma 20 volt. If your graph is starting from the origin, choose origin as one of the coordinates, x1, y1, x2, y2. To find the slope, the equation is m equals y2 minus y1, so 20 minus 0 over x2 minus x1, 2 nanocoulombs minus 0, 20 over 2 nanocoulombs. Nano is 10 to the power minus 9, so 20 divided by 2 times 10 to the power minus 9. 20 by 2 is 10, 10 times 10 to the power of 9. Yeah, that's the slope. But we need to find 1 over slope. So 1 by m equals 1 divided by 10 times 10 to the power of 9, which is 10 to the power of minus 10 farads. Or 1 times 10 to the power of minus 10 farads. If you need to convert this into nanofarads, move the decimal place. So nano is 10 to the power of minus 9. We have 10 to the power of minus 10. So add 1 to the power. If you're adding 1, you have to move the decimal place to the left. So 0.1 times 10 to the power of minus 9 farads, which is 0.1 nanofarads. There is an easy way to solve this. If the graph is starting from the origin, then you can choose any point on the graph. Choose any point on the graph. Let's say I'm choosing this particular point here. The coordinates of this point is 1 nanocoulomb and 1 nanocoulomb, comma 10. Yeah, so Q corresponding to this point is Q equals 1 nanocoulomb. 1 nanocoulomb. Right? Q corresponding to this point is 1 nanocoulomb. And delta V corresponding to this point is 10 volt. Delta V equals 10 volt. And what's the equation for capacitance? C equals Q over delta V. Q is 1 times 10 to the power minus 9 over 10, which is 10 to the power minus 10 farads. Get the same answer. We use this shortcut only if the graph is starting from the origin, or it wouldn't work. Yeah. Okay, so let's do the second one. Slope of capacitor B. I'm doing the proper way. So we have to find 1 over slope. Again, I'm going to choose 2 points. I'm going to choose this point, 1 nanocoulomb. 1 nanocoulomb, comma 20. Because it's starting from the origin, I'm choosing 0, 0 as the second point. Again, you can just use Q by delta V here to directly find the capacitance. The Q is 1 nanocoulomb, so 10 to the power minus 9 over 20. I'm going to do it in the proper way. I'm going to find the slope, then I'll find 1 by slope. Yeah. Slope is m equals y2 minus y1 over x2 minus x1. I have 2 coordinates here. I'm going to call this x1, y1, x2, y2. So y2 minus y1 is 20 minus 0, which is 20. 20 minus 0 over x2 minus x1, 1 nanocoulomb minus 0. 1 nanocoulomb minus 0. 20 over 1 nanocoulomb. 20 divided by nano is 10 to the power minus 9. Yeah, that is my slope. To find the capacitance, we need to find 1 over slope. 1 by m equals, flip this, 10 to the power minus 9 over 20. 0.05 times 10 to the power minus 9 farads, which is 0.05 nanofarads.